right, so now we're looking at a closer look at the neuromuscular junction. This is the axon coming in, and we know that there was vesicles in here with acetylcholine, and the acetylcholine diffused across due to exocytosis of these vesicles from calcium coming in. So that's where we are. So now this acetylcholine is coming in, and it's going to bind to these receptor sites on these chemically gated channels. And when that happens, those channels will open. Those chemically gated channels allow for the flow of sodium and potassium. So sodium is on the outside of the cell, so it is going to flow in. Potassium is on the inside of the cell, so it is going to flow out. Okay, so that just makes sense, just by diffusion, by its gradient. But keep in mind that there are always more channels for potassium on a cell, any cell, whether it's a muscle cell or not, or some other cell, it's always going to have more potassium channels. And I mean leaky channels. So there's always potassium leaving the cell. So that means that when these gates open along the motor end plate, there's going to be a higher gradient for sodium. So sodium will flow by a higher concentration gradient than potassium. Okay, so that means that the inside of the cell is going to get positive. The inside of the cell at the motor end plate is going to get positive. It's going to get above negative 70 millivolts because there's more sodium coming in, and it's a positive ion, than there is potassium coming out, which is also a positive ion. But since there's less coming out, it's going to cause this voltage at the motor end plate to become more positive. Okay, so due to this fact of the sodium coming in at a higher gradient, so it's coming in faster, the motor end plate will get more positive. Okay, so it'll go above negative 70. So remember, this to here is the motor end plate. And when we have that movement of sodium coming in like that, it's going to create the motor end plate potential. So basically that means that the motor end plate is energized now. So motor end plate is, we'll say that's energized. Okay. So we need for the action potential to go along the entire sarcolemma. Okay, so now that it's here, so we have that end plate potential, which is above negative 70, the sarcolemma over here is still at resting at negative 70 millivolts. Okay, over here as well. Okay, so what happens is there are gates on either side of the motor end plate So here, and we'll put them here. And these are specific for sodium. And they are also voltage gated. So they're not always opened. They have gates, but they're voltage gated channels for sodium. And when this end plate potential occurs, it will open these gates. And sodium will come into the cell. That will create the action potential along the sarcolemma. So this starts the action potential. When that gate opens due to that change in potential, it will also then open a voltage gated channel for potassium. And potassium will go out. Same thing over here. Potassium will leave. Okay? Then the next channel will open. And we'll have the influx of sodium. And then the next one will open, and we'll have the outflux of potassium. And it will keep doing that all the way down the sarcolemma. That is called propagation of the action potential. Okay, now see here that the sarcolemma is not going to go straight across. It's going to go into the T-tubules here. Okay, you can see that here's the T-tubule, and it's going down into that. So there are these channels going down into the T-tubule as well, because this is just sarcolemma. Okay, so that's here too. All right, so the action potential goes down into the T-tubules, and it will run into some structures that will help open the sarcoplasmic reticulum and release calcium. Well, meanwhile, back here at the motor end plate, remember we still have acetylcholine here. So what happens to the acetylcholine? It can't really stay there, because if it does, then you'll have contraction or action potentials occurring on the sarcolemma without neurologic stimulus. Okay, you'll just have weird contractions going on. So at the motor end plate, once the motor end plate potential is achieved, is established, acetylcholine is removed from the cleft. And it's removed by an enzyme called acetylcholine esterase. And that will stop the motor end plate from being energized any further. Okay, so we only want one motor end plate potential per contraction. All contractions have to be stimulated by the central nervous system. They can't just happen arbitrarily. Okay, so at this point now we have our action potential on the sarcolemma. It's being propagated across the sarcolemma and into the T-tubules. Okay, so now we'll talk about the rest of it in the next video.